to all. Today we'll discuss an example for chi-square test. So here we have a data of smoker and non-smoker, and in that female and male did they will smoke or not. So what we have to do means we have to find out the association between the gender and smoking habits. So we'll make this table to be complete. So we'll consider means we'll add this a and we'll add this 18 plus 8 will get around a plus b, so which is 26. So next we'll add c plus d. 8 plus 24 will get around 32, so which is nothing but our c plus d. So followed by same we'll do as a plus c. We are adding the characteristics of a, this male and female and smoker, and of this column will get the value around a plus c. So same as that we'll add 8 plus 24 will get as 32, which is nothing but b plus d. So this is our 58. We'll plus this will get 58, or else we'll plus this will get 58, so which is nothing but our total number of observations. So we have 58 total number of observations. So very next step is next step here we'll do framing an hypothesis. We'll frame a null hypothesis. So null hypothesis says that there is no association, or else there is no significant association between gender and smoking habits. So what this is says that means after framing this hypothesis, after calculating everything, we'll compare the table value and calculated value, and again we'll consider and we'll frame another hypothesis, that is final conclusion hypothesis. So to calculate chi-square test, we have a formula, that is observations and e divided by e, and which is e whole square. So we'll do one by one. So we have O. So we have totally 4 observed frequency here, so which is nothing but each cell 18 and 8 24. So this is our observed frequencies. Next we'll find out the expected frequency. To calculate expected frequency, we'll go through with the that contingency table. So to calculate this expected frequency, firstly we have a characteristic, that is 18. So 18 so concurrently we have 26 for 18 and similarly in this row we have concurrently 26. So what we have to do is we have to multiply 26 into one more 26 divided by we have a total observations as 58. After dividing this we'll get is equal to 11.65. so this is our expected frequency, and we'll put this value into this. So we have 11.65. Similarly we need to calculate for, this is for 18th one, we have to calculate for 8. So for 8th cell we have 8, we can take this 8 and this 8, nothing will happen. So after A we'll go for B. So for B this is 32 concurrent value, and this is 26. So what we have to do is 26 into 32 divided by 58. So we'll get we'll get around value of 14.3. so we'll keep this as 14.3. Similarly for this 8 also we have a concurrent value of 26 and 8's concurrent, that is 32. So no need to calculate again. So this is going to be same for both of them. So next we have to calculate for 24th cell. So 24th cell, so concurrent or corresponding is 32 and this is also 32. So we have to do is 32 into 32 divided by 58 is equal to, it's around going to be a 17.65. so we have to keep this as similar only, 14.3, and below that just now only we found it that 17.65. so this is going to be 17.65. so what we did, we calculated observation frequency and expected frequency. So next we have to calculate, that is observation frequency minus expected frequency. So 18 minus 11.65 will get the value around, it's going to be 6.35. so similarly as 8 minus 14.3 will get this value to be negative because 14 is bigger than 8, so this is 6.35 again, and this is similar to this. And 24 minus 17, 6 will get this will also same 6.35. so what we have to do next is observed frequency minus expected frequency whole square. So we have this value as 40.32. After for calculating this we need a calculators, and for both we have similar values, that is 39.69. so after squaring this 6 will get same value, that is 40.32. so our next step is what we have to do is observed frequency minus expected frequency whole square divided by E. So we have to divide this by this value, so we'll get different values, that is 3.46 initially, and 39.69 divided by 14.3 will get around 2.81. Similarly we have similar means we'll get similar, that is 2.81 itself, so followed by 40.32 divided by 17.65 will get around 2.28. so we have to add this total value, so summation of chi-square will get around after calculating 11.36. so this is going to be our chi-square, so chi-square is equal to 11.36. So we have another simplest method to calculate chi-square test if the contingency table is 2:2. So the formula is chi-square is equal to n, capital N, into AB minus BC whole square divided by A plus B into B plus C into C plus A into B plus D. So I kept here A, B and all for this formula itself. So directly we'll keep that values into this formula. So n is, we have a 58. So this is our total number of observations. So A into B we have to do A into B, 18 into 8 will get around whatever we'll get, we'll keep this directly 18 into 1 second please, small correction, we have to do like this, A into D and C into B or B into C. So will 18 into 24 we have to do A into D, so 18 into 24 minus B into C. So we have that B and C similarly, that is 8 into 8 divided by we'll put the values directly, A plus B, we have 26, or else we can keep this as 26, or else we can keep normal casual values, that is A is 18 plus, similarly B is 8 like this, and B plus C we have 26, that is 8 plus 8 plus 8, and next value we have, that is C plus A, a plus c, which is nothing but 18 plus 8, 18 plus 8. And similarly we have b plus t. So b plus t, 8 plus 24, 8 plus 24. So adding these values, so it's equal to 58 into we'll get 432 minus 64 whole square, sorry I didn't kept here whole square, divided by this is around 26 into 32, no 26, 18 plus 8 and 26 and 32, 8 plus 24, it's going to be 32. So what we have to do is we have to multiply. This is going to be our 58, and after simplifying this we'll get as 416 whole square divided by after multiplying these all values we'll get the value as 69224. So after squaring this, after removing this square and multiplying with this, we'll get the value as around 7854592 divided by 69224. So after dividing this we'll get the value around 11.34. So chi-square test is equal to 11.34. By using two formulas we took the answer as chi-square as 11.36 and here chi-square as 11.34. So next step we have to do is we have to calculate degree of freedom. So degree of freedom, we have total columns minus 1 and total number of rows minus 1. So totally we have 2 rows and 2 columns. So this is our 2 rows and 2 columns. So 2 rows minus 1, 2 columns minus 1. So 2 minus 1, which is nothing but 1 into 1. So we have a degree of freedom as 1. So hence the alpha level of significance at the table at 0.05 we have 3.841. in table value we have to check that the level of significance of 0.05 and degree of freedom 1 will get the table value of 3.841. in some questions they'll give in exam this table value. Directly we have to calculate and we have to keep the values. So we have to frame inference here. So our calculated chi-square test, inference. So chi-square test calculated value is 11.34 and which is more than chi-square table value which is 3.841. so hence our H0 is rejected. So if our H0 is rejected means what we have to do, we have to frame alternative hypothesis. H1 or H alpha is equal to there is significant association between gender and smoking habit. So in exam also we have to do each and every single steps. First step I said that framing of hypothesis, followed by calculation, followed by comparing the table value and alpha significant value and the calculated chi-square value. So if the chi-square value is less more than the table value, means if the calculated same in the scenario, if the chi-square calculated value is more than the table value, then H naught is rejected. But if the chi-square value calculated value is less than the table value, then H naught is going to be accepted. So finally, in inference we need to mention that H naught is accepted or rejected. If accepted means we can frame H naught hypothesis, or else no need, because already we framed in initially. If H naught is rejected means we need to frame compulsorily alternative hypothesis. So here we'll finish it out, and I'll give an example to calculate chi-square similarly. So here is our example. 46 rabbits are divided into two groups. Each group of 23 rabbits are experimental groups inoculated against the disease, and control group is not inoculated. All the rabbits of each group exposed to the disease, and in controlled group 13 rabbits contracted, means they got diseases, and in the experimental group 8 rabbits are got the disease. Test whether inoculation and contact of disease is independent. So at the significance level of alpha, table value is 0.02, means they didn't given the table value, but they have given significance level at 0.02 level. We have to check the table value. For that we have to calculate. Initially we need to frame H naught. So this is a table, a positive and negative control group and experimental group. So total, and here total, this is table value. By using this you can calculate, and the table value for just given example is at the level of 0.02, the calculated the table value is going to be 5.024. So at the significance level of, which is nothing but alpha, 0.02, the table value is 5.0. So you have to compare this table value with the calculated value. If which is more than this value, means H naught is rejected. If the calculated value is less than this table value, means H naught is going to be accepted. Thank you.